Okay, so angles of polygons. So I want to talk about equilateral, equiangular, and regular polygons. Equilateral means that they have congruent sides. So you might think of an equilateral triangle. I'm going to draw a pentagon instead, just to show that it doesn't have to be a triangle to be equilateral. It can be any polygon where all of the sides are congruent. Okay, and equiangular, all of the angles are congruent. So I'll stick with pentagon here. Um, if all of the angles are congruent, then it's equiangular, okay? And a regular polygon is when both of these things are true. All of the sides are congruent and all of the angles are congruent. So obviously these are not the best sketches in the world, but it's good enough to show what I'm trying to show. So that would be a regular polygon, okay? And then we've already talked about the names of polygons earlier in the book, but I'm going to go over some anyways. I didn't put three-sided on here. That's a triangle, so I'm not even going to bother with that. But you should know that four-sided polygon's a quadrilateral. Five-sided is a pentagon. That's what I just drew up there. Six-sided would be a hexagon. Seven-sided is a heptagon. Sometimes I've seen that called a septagon, and I would be okay with that, but I'm going to stick with heptagon because that's what our book uses there. Octagon is 8. Nonagon is 9. Decagon, think of a decade as 10 years. Decagon has 10 sides. 12-sided figure is a dodecagon. Okay, you might notice I skipped 11-sided figure and I forgot what it's actually, oops, that's off screen. I forgot actually what it's called. I know it has a name. But these are the ones that you need to know. You probably already know most of them, if not all of them. I find that the ones that people forget are the heptagons, nonagons, and dodecagons. So maybe review those if you don't know those. Anything else, you can just call it like an 11-sided polygon. We would call it an 11gon. If it has 84 sides, it can be an 84gon, and so forth. Okay. All right. So let's move on to the next page. I'll just start here in case you're still copying that down. Okay, so this we've got the triangle angle sum theorem. This is old news. The sum of the three angles of any triangle is 180 degrees. Okay, so hopefully that's not a shock. Okay, I just put that up here because we're going to use that when we're finding the sum of the interior angles of any polygon. Okay, so here I've got something that clearly is not a triangle, and if you count it up, let's see, 1, 2, 3, 4, 5. This would be a pentagon. Okay, so let's find the sum of the interior angles. So one way to do this is to pick a vertex, any vertex you like. I'm picking this one just because I like that one. Okay, but you could do this with any of them. And then I'm going to draw in all of the diagonals. Okay, so diagonals are segments that connect two vertices, but they're not going to connect two adjacent vertices because then that would just be a side. But if I draw a line like this, that is a diagonal, and then that is a diagonal. So I'm just going to draw the diagonals from that corner. There are other ones that I could draw in the figure, but I'm just going from that corner, okay? And now what I've done, I've cut this up into 3 triangles, okay? So what I can do is I can think about, well, hey, what would the sum of these 3 angles be? Well, it's a triangle, so that's going to be 180 degrees, right? And then what would the sum of the, I've got these ones marked blue, those sums would also be 180 degrees, and so would these. Okay, well, so what? Well, if you think about all of the interior angles of the pentagon, well, there's one, But then if I add those two together, that's another one, right? And if I add these three together, so really if I take up all of the smaller angles that I have with the orange, the blue, and the red angles there, if I add those all together, then that will be the same as the sum of all of the interior angles, right? Because these three together are going to make that corner, okay? So, hey, I know I've got 180 degrees there, 180 degrees there, and 180 degrees here. So what I can do is just think of the sum is always going to be equal to the number of triangles times 180 degrees, because each triangle gives me 180 degrees. Okay, so in this case I've got 3 triangles when I cut that up times 180 degrees, and that would give me a total of 540 degrees. Okay, so next problem we've got, this is not a pentagon anymore, it's a 1, 2, 3, 4, 5, 6. This is a hexagon. So you can go ahead and pause it and try it with this one if you like. So I'm going to cut this up into triangles. I'm choosing this corner this time. I don't know why, just like that one. Doesn't matter which corner you choose. When you cut it up, you'll get the same amount of triangles. So I'm cutting it like that, and I can see, okay, I've got 1, 2, 3, 4 triangles. So my sum is going to be the number of triangles, which is 4 here, times 180 degrees. And that's going to give me a total of 720 degrees for the sum of the interior angles. Great! Okay, so just cut it up into triangles. So let's try this next problem. Well, I'm going to skip this a little bit for now. Okay, let's go down to this problem. Find the sum of the interior angles of a 37, Garn. Well, I don't want to draw a 37-sided polygon and then cut it up into triangles. And there's no picture here either, so that would be a huge pain. I mean, you could do that. But instead of doing that, let's look for a pattern, okay? So when I had, this one had 5 sides, right? It had 5 sides, and we ended up with 3 triangles. Okay, on this one we had 6 sides, and we ended up with 4 triangles. So wait a second, I'm seeing a pattern here, okay? I had 5 sides, 3 triangles, 6 sides, 4 triangles, so I'm guessing if it's going to be 7 sides, then it would have 5 triangles. And that pattern is going to hold true. So the number of sides, if you subtract 2 from that, that'll give you the amount of triangles, okay? And from that, we can construct a little formula. So the polygon interior angle sum theorem is going to look like this. Okay, n minus 2 is going to represent my number of triangles. That's if n is the number of sides. Okay, so the number of sides minus 2 gives you the amount of triangles, and then you just multiply that by 180, okay? Also, in some of these problems, it might be worth noting that the number of sides is going to be the same as the number of angles. A triangle has 3 sides, 3 angles. A quadrilateral has 4 sides, 4 angles, and so forth, okay? But I'm going to put that piece aside for later. But now I can use this formula. I don't need to do a drawing. So let's see, my sum here, I'm going to take n minus 2. Well, my n is the number of sides. 37 has 37 sides. Subtract 2 from that and multiply by 180. The most common mistake I see on these, people just do 37 times 180 instead of 37 minus 2 times 180. Okay, so here I've got 35 times 180 degrees, and that's going to come out to 6,300 degrees. So I'm glad I didn't spend time trying to draw that out and cutting it up into triangles, because it would have taken a while, right? I would have ended up drawing 35 triangles. Okay. All right, let's try another problem. Next page. This one says find the number of sides of a polygon. Okay, so it means I'm going to be trying to find the n, right? N is the number of sides. And this time it tells me what the sum is. So let's get the formula out again. We're going to use the same formula. Okay, and I've just got some different pieces. This time I don't know what the n is, but I do know what the sum is, right? The sum is 2,520 degrees. Okay, so now I'm trying to solve this for n. Now, a lot of people will distribute the 180, and nothing wrong with that. Nothing wrong with that at all. But for me, I'm just going to prefer to divide the whole equation by 180, okay? Because then those are gone, and I'm going to get a calculator out here. Let's see. That's going to come out to 14. Okay, and the common mistake I see here, I get a lot of, if it's, I see this final answer a lot. People just say, oh, it has 14 sides because they just took the sum and divided by 180. But you got to remember that's what n minus 2 equals. Okay, so that's like, there's 14 triangles if you cut it up, but that's not the number of sides. Still have to add 2 to both sides here, and so my final answer is going to be 16, not 14. Okay, there's the number of sides. It would be a 16gon. Okay. All right, let's try another one. This says find the measure of one interior angle of a regular 11gon. So you got to remember that regular means all sides and angles are congruent. The sides aren't really going to matter here, so I'm just going to say all angles congruent. Okay, and that means I can use another little formula here. Okay, so I know whatever the sum of all of the angles. The sum of all of the angles is n minus 2 times 180. Okay, so I'm going to move down here to this next little part. This is all of the angles. Okay, and then for just one interior angle, if it's a regular polygon, has to be regular, then those angles are all going to be congruent. And the number of angles is the same as the number of sides. So, you know, if this is a hexagon, then n would be 6, right? And that means I'd also have 6 angles, okay? So you can use this formula to find one interior angle, but only if it's a regular polygon. If it's not regular, you can't use that little formula, okay? So let's try this one out. So I'm going to use n minus 2 times 180 degrees over n. So I'm just going to say one angle is going to equal this. Okay. All right. So n here would be 11. And then I'm going to put 11 in the bottom as well. Okay. So I'm going to do the parentheses first. I got 9 times 180 divided by 11. All right. Calculator here. 9 times 180 gives me 1620. Run out of space here. 1620 degrees, 1,620 degrees divided by 11. And then I've got 147.27 repeating. Okay, so that 27 repeats, so I'm going to go like that. You could also round to the nearest 100th or 10th, I suppose. But there we go. That's what the measure of one of those angles would be. Okay. All right, and then next up, a regular polygon has an interior angle that measures 150 degrees. Okay, how many sides does it have? Okay, so again, this is a regular polygon, so I'm thinking, okay, let's use this formula. Okay, so so I'm just going to say one angle let's think what we know here. It has a measure of 150, so I know what the one angle is equal to. Okay, this one is a little trickier than the other problems to solve because I've got two different n's. Okay, so I have to isolate n here. It's going to take a little bit more work. What I like to do first thing off is to get rid of my fraction. So if I multiply both sides by n, then no more fractions, right? So now I've got 150. This is going to be the number of sides, so I'm not going to bother putting in the degrees everywhere. Okay. Okay, and you got some different options, but what I'm going to do next is to distribute the 180. Okay, so far I've really just simplified the equation. There's no more fractions, and there's no more parentheses either, so it's easier to work with. Okay, and now I can solve this for n. I'm going to subtract 180n from both sides, and that gives me negative 30n is going to equal negative 360, and then divide both sides by negative 30. Okay, those will cancel, and n is going to equal 12. How many sides does it have? It has 12 sides, because that's what n equals. Okay. All right, on to this next page. I'll leave that up for a second. Here we've got, this looks like it's a regular polygon, but clearly it's not if you look at the numbers. So it's a bad drawing. It's not to scale. But I'm going to go with the given information. I can see how many sides it has. So let's see, 1, 2, 3, 4, 5, 6. This has 6 sides, okay? So you can, what I want to do first is find the sum of all of these angles. I'll put this down here. I'm going to find the sum. And then I'm going to write an equation to solve for x, okay? So here's my process, okay? Let's find the sum. So I'm thinking the sum is going to equal n minus 2 times 180 degrees, okay? I'm not doing the divided by n. That's just if I'm looking for one angle of a regular polygon. That's not the case here. Okay, so n is going to be 6. And that's going to come out to 720 degrees. Okay, so phase 1 complete. I found the sum. Now I'm going to write an equation. And my equation, that's saying what all of these add up to, right? So I can just say, okay, x plus 118 degrees plus 111 degrees, and I'll work my way around. Hopefully I'm not going to miss any of these. Okay, if I add up all of those angles, then I know I'm going to get 720 degrees, right? That's why I did phase 1, so I know what those would all add up to, okay? And now it's just a matter of doing the arithmetic over here. I'm going to combine all of those like terms, okay? So when you add up all of those on the left, you're going to get 613 degrees. And then subtract 613. Okay, and then x, I'm not putting the degree symbol in my final answer because it's already in the diagram, right? I'm just showing what number x would be in this diagram. Wouldn't be the end of the world if you put degrees, but technically don't need it there. Okay, all right. All right, moving on. We've talked about the interior angles of polygons. Let's talk about exterior angles of polygons. Okay, so on this next problem, we've got, or this next diagram, I guess I should say, we've got exterior angles. So remember, exterior angles happen when you extend the side of a polygon, and this would be an exterior angle right here. Okay, so this is an exterior angle. Well, let's figure out what that would be. Well, I've got a linear pair right there, right? So I know this angle plus 60 degrees is going to equal 180. So that's going to be 120, right? And hey, I got the same thing over here, right? This plus 60 is going to be 180. And the same thing right here. So there's my three exterior angles in this diagram, okay? And let's see what happens when we add those up. So my sum here of the exterior angles oops, I was supposed to say 120. I'm going to get 360 degrees. Hey, that's one of my favorite numbers, 360, right? Especially when we're talking about degrees. Pretty famous number. And it actually turns out that it doesn't matter what type of polygon you have. If you extend all of the corners, I was thinking of a rectangle in my head, but if you extend all of the corners, if you take all of these angles, doesn't matter, any polygon with any number of sides, if you add up all the exterior angles, it's always going to be 360 degrees, okay? So okay, what's going on? That's supposed to say 360 degrees there, okay? So the polygon exterior angle sum theorem is that the sum of the exterior angles is always 360 degrees. Just got to remember that, okay? All right, that is the end of the section. I'll see you next time.